Okay, let's play from the current slide. Okay, so let's talk about some examples here. The first law of exponents says that x to the a times x to the b is x to the a plus b. What are we talking about here? This looks nuts. Well, let's make it more concrete. Let's say x squared times x cubed. Well, x squared is xx, x cubed is xxx. And if you look there, all together, over those two lines, the line on the left meaning x squared, the line on the right meaning x cubed, altogether there are 5 x's. This is a series of factors. Each factor is x, and there's 5 of them. So that is the very definition of x to the 5th. So x squared times x to the 3rd is x to the 5th. And what's strange here is clearly you're multiplying x squared times x cubed, but you're not multiplying the exponents. You're multiplying the term x squared times the term x cubed, but you actually end up adding the exponents x to the 5th for the reason that I just showed you. X squared, x cubed, underline, there's a total of 5 x's there, so it's x to the 5th. And a good example would be if I did x to the 4th times x to the 8th, it is not x to the 32nd, it is x to the 12th. Okay, next one up. Actually, I want to jump down. I want to do the last one. Okay? Doing the last one, x to the a over x to the b. In other words, if I'm dividing, I actually end up subtracting the variables. So for example, if I did x to the 12th divided by x to the 3rd, I would get x to the 9th. So I subtract. 12 minus 3 is 9. Notice the answer is not x to the 4th, it's x to the 9th. If I look at the last one, I get, this time I put in a coefficient, 15 divided by 3 is 5, and n to the 8th over n to the 4th is n to the 4th, not n squared, it's n to the 4th. Subtract those exponents just like the rule tells you to do. So I'm kind of developing a working theory here. Let's see what you think. So with these laws of exponents, as long as the base stays the same, and you'll notice in each of these the bases are the same. If I'm multiplying the bases, I add the exponents. If I'm dividing the bases, I subtract the exponents. Now, addition is repeated multiplication. It's a step down from multiplication. Subtraction is division is a bunch of subtractions in a row. So subtraction is a step down from division. So here, what we're looking at here for each of these rules is everything is a step down. So let's look here, x to the a to the b. So it's raising a power to a power, the a power to the b power. And a step down from exponents is multiplication. And look, that's exactly what you get. X to the a to the b is x to the ab. So x squared to the 3rd is x to the 6th. Prove it? Sure, I'll prove it. X squared is xx, and cubed means use it as a factor 3 times. So I get xx, xx, and xx. Altogether there are 6 x's there, so it's x to the 6th. And an example is if I did 3n to the 5th, and I squared that, I have to square everything in the parentheses. 3 squared is 9. I still square the number as usual. I only change up when I'm doing exponents. N to the 5th squared is not n to the 25th, it's n to the 10th. So you may want to take a picture of this particular slide for your photo album on your phone. A little more insight, okay? As far as the laws of exponents go, another example here, x to the a times x to the b is x to the a plus b, add them. X to the 5th times x to the 2nd, adding 5 and 2, I get 7. How come? Because x to the 5th is xx, and x to the 5th is xxxxx, and x squared is xx, and altogether there are 7 x's there. What about if I do x to the a over x to the b? Now I'm going to subtract exponents. So notice multiplication of the bases becomes addition of the exponents. Division of the bases becomes subtraction of the exponents. 6 divided by 2, x to the 6th divided by x squared, it's not 3, it's x to the 4th. Subtract those exponents. How come? Because look across the top, that's x to the 6th, and 6 x's. X squared is 2 x's, and we could cancel out or die or kill 1, 2. That leaves 4 left, x to the 4th. And as far as x to the a to the b is x to the ab goes, an example, 5x to the fourth squared. 5 squared is 25. X to the fourth squared is x to the eighth. An explanation, this is 5x to the fourth. 5x, x. 5 times 5, because you're squaring it, I have to write it twice. 5 times 5 is 25. X to the fourth times x to the fourth is x to the eighth. Okay, so those are two slides that really show you the why this is, where it comes from, so it makes sense. Now you're going to try these 11 questions, and then we will go over them. On my end, you're going to do stop and stop. On my end, I'm going to pause about 5 seconds, grab a sip of my bye, and then go over the answers. Okay, x to the second times x to the third is x to the fifth. Add those exponents. Next one, multiply coefficients, add exponents. 5 times 3 is 15. Remember, there's really a little 1 on top of this n here. We don't bother writing it, but it is there, so 2 plus 1 makes 3. Next up, 3 times negative 7, because you're going to multiply coefficients, add exponents. 3 times negative 7 is negative 21. And then 3 and 5 make 8. 4 and 4 make 8. And 1 and 3 make 4. So a to the third times a to the fifth is a to the eighth. B to the fourth times b to the fourth is b to the eighth. And c to the 1, even though we don't bother to write it, it's there, times c to the third is c to the fourth. Okay? Let's do 4, 5, and 6 now. Number 4, subtract exponents. That's x squared. Next one, divide coefficients, subtract exponents. Negative 20 divided by 10 is negative 2. And then n to the 7th over n to the 4th is n to the 3rd. Subtract those exponents. Next up, negative 14 divided by negative 7 is 2. And a to the 10th over a to the 5th is a to the 5th. And b to the 5th also, because 8 minus 3 is 5. Okay, let's try numbers 7, 8, and 9 now. Number 7, pretty direct. The first column is real simple, straight out of the textbook. N to the 5th to the 3rd, when I raise a power to a power, I multiply. That's n to the 15th. Next one, I've got to raise the 2 to the 4th power as well as the v to the 3rd. So 2 to the 4th is, oh, look, I didn't do that. Oh, we are going to have, don't, play from current slide. This here, and now, good. Remember, we have to do the 2 to the 4th power and the v to the 3rd to the 4th. So 2 to the 4th is 16, right? 2 times 2 times 2 times 2, that's 16. And then v to the 3rd to the 4th, when you raise the power to a power, you multiply, that's v to the 12th. Next up, 5 to the 3rd is 125, and then raise a power to a power, you multiply, that's x to the 9th. Y to the 12th, remember that z is to the 1, and 1 times 3 makes 3. So that's z to the 3rd. Number 10. If x to the a times x to the 5 is x to the 9, what's the value of a? Well, remember, you add exponents. So a plus 5 equals 9. A is 4. And number 11, when you raise a power to a power, you multiply exponents, you do the power onto the coefficient. So 3 to the 4th is 81. We're good there. But then I have x to the 4th to the 4th, giving me x to the b. So when I raise x to the 4th to the 4th, that's x to the 16th, so b has to be 16. As far as the a goes, I have y to the a to the 4th, and that gives me y to the 20th. Well, what number times 4 is 20, or divide both sides by 4, and you get that a is 5 and b is 16, okay? I know you solved for b first, but a is 5, b is 16. Okay, happy recap. I didn't do any recaps on the laws of exponents, so I'll do that verbally. Get the linear equation into y equals mx plus b form. Identify the slope and y-intercept. That's how you solve simultaneously, right? Why do we use an m for slope? Because it's how you move. B for y-intercept, because it's where you begin. If they're simultaneous, graph each line individually, find that point of intersection. That's your solution. As far as algebraic technique of simultaneous equation goes, if everything aligns, it's elimination. If they do not, it's substitution. Now, what we learned about today was the laws of exponents. It basically says when the bases are the same and you multiply, you add exponents. When the bases are the same and you divide, you subtract exponents. And when the bases are the same, or the only base, and you raise a power to a power, you multiply those exponents. That was the gist, the guts of today's lesson.